This video will discuss question 8, which is a true-false statement that goes as follows. The open loop gain of the oscillator in figure 1 decreases at increasing signal levels if all diodes except D7 and D8 are removed. First, to simplify this drawing a little bit, let's remove all diodes which will not be used in this question. The open loop gain of this oscillator can be seen as the multiplication of this network, of these three RC sections, multiplied by the transfer of this unity gain buffer, and then multiplied by the effect of this amplifier. Now, since the effect of this beta network is going to not be influenced by these two diodes, and this unity gain buffer doesn't really have an effect on the magnitude of the signal, we're just going to look at the amplification factor of this section of the circuit, since that's going to determine whether the open loop gain is going to increase or decrease for larger signal levels. The amplifier here is in what we call the inverting configuration, and in that case the gain A from input, which is VB, to output VC, is negative. The resistance of the output to this inverting input, so that's R5, over the resistance from this inverting input to the input of your amplifier, so that is R4. The potential at this inverting input will be ground, and we can see that by the fact that the non-inverting input is directly connected to ground. So that means that one of these two diodes will start to conduct if VB is larger than or smaller than 0.7 or negative 0.7 volts. These diodes are modeled as ideal switches, which is given here in the caption. That means that when the potential is large enough here, we will have a short circuit from VB to this inverting input. And as a consequence, the resistance in this path, which would be R4 without this diode, would then become 0 ohms. And that means that the gain of our inverting amplifier will increase tremendously. So the open loop gain of our oscillator will actually increase for an increasing signal level if these two diodes are in the circuit. So the statement above has to be false.